Welcome back everybody to 3 Inquisitive Kids. In this video we will be covering polyline graphs, our last lesson of this chapter. So this is our last video of this chapter, and as you can see we've been talking about variables, tables, equations. In our last lesson we talked about non-linear relationships. In this lesson we're going to talk about another type of graph, polyline graphs. Here's some review. We first learned about tables. The following table lists the situation a store is in. The original price of a product X is $450. With price reduction, the number of daily sales changes. And this is our table. This top row is indicating how much dollars is getting reduced. At first the store takes off $5, then it takes off $10, then it takes off $15, and then as it gets cheaper and cheaper, more people are starting to willing to buy it. This table reflects a relationship between two variables. So the price reduction would be the independent variable, and the daily sales is the dependent variable. We also learned about functions. A taxi consumes 5 kg of fuel per hour. If it consumes Q kg of fuel in T hours, then the independent variable is blank and the dependent variable is blank. And the relationship between Q and T is expressed as blank. So T would be the independent variable because it's indicating for how long the car has been driving. And Q would be the amount of fuel consumed. When you write this in a mathematical function, it would be expressed as Q equals 5T. Here is nonlinear graphs. The graph below shows a change of water level in a certain port from 12 o'clock to 6 o'clock on a certain day. Here's our graph. Number 1, at about which hour is the water the deepest? Number 2, what does point A represent, and what is the changing trend of the water level from 12 o'clock to 6 o'clock? So let's answer these questions. You can see that at its deepest level, the water rose at 3 o'clock, so that would be 3 o'clock. Point A represents how deep the water is at the 4th hour. The changing trend of the water level from 12 o'clock to 6 o'clock is first increasing and then it decreases. There is a speedometer on every car to indicate the current speed of the car. How do you read it? Of course, some of you might know how to drive, some of you might not know how to drive. But here's a word problem based off of a speedometer of a car. When a car is running, its speed changes. The graph below shows how the speed of a car changes with time. So it seems like this car is starting to accelerate, pick up speed, and then it starts driving at a constant rate. Then it slows down because it needs to pause at some place. It rests for a bit, it keeps accelerating to a faster speed, it drives at the speed for a while, and then it slows down and pauses again. Number 2, the car keeps driving at a constant speed during blank. The speeds are blank and blank. For the first question, we have to look at the x-axis. This is telling us what the time/minutes is. You can see that the car drove until the 24th minute, so it took 24 minutes to drive the entire trip. And the car was at its top speed when it was driving at 90 kilometers per hour. Number 2, the car keeps driving at a constant speed during 2 to 6 minutes. So this, and 18 to 22 minutes. We are talking about intervals here. The speeds are each 30 km per hour and 90 km per hour. Here's some practice. Kanban takes a train home from school. He starts from school and walks to the train station at a constant speed. After waiting for a while, Kanban boards the train and goes home. The relationship between the distance between Kanban and his house and the time, x, is shown in which of the graphs. We can start to eliminate some of these options. At 0, Kanban's distance from home should be very high because he's not at home yet, which means we can eliminate A and B. So he walks to the train station at a constant speed. Remember, he's walking. After waiting for a while, so the distance from home never changes, which means that there needs to be a horizontal interval, Clement boards the train and goes home. And the train should be pretty fast. Since we know that the train is actually faster than walking, the slope of the train should be steeper than the slope of walking. So our answer would be D. The persimmons ripen and fall from the tree. Which of the following pictures best represents the speed of the persimmons during the fall? So you might not know this, but when something is falling, it actually starts getting faster and faster. So at first, the persimmon is resting on the tree, then it starts to fall, but then its speed gets faster and faster and faster and faster. So our answer would be number 3. A bus departed from the station and starts accelerating and then continues to drive at a constant speed. When the bus arrives at the next station, it slows down and then speeds up before passengers get on and off. Again, it continues to drive at a constant speed. Which of the following correctly represents the relationship of the bus's speed and time? So again, we were talking about the relationship between speed and time. So let's follow this along step by step. It departs from the station and then starts accelerating. Then drives at a constant speed. So it's definitely not D. We need some acceleration, and it's not A. And then it needs to drive at a constant speed. You can see that in option C, it never has a point where it drives at a constant speed. That would be represented as a flat line. So our answer would be B. On Sunday, Karen biked to the countryside. The relationship between Karen's distance from her house and time is shown in the graph. Answer the following questions according to the graph. Number 1. When was Karen furthest from her house? What was the distance? Number 2. When did Karen start her first break? For how long did she rest for? So it took Karen 3 hours to reach the furthest place from her house, which was 30 kilometers away. I'm sorry guys, this is not 3 hours. As you can see, it's 12 hours, if you look at the graph. Karen had her first break at 10:30 and she rested for half an hour. As you can see at 10:5, this is 10:30. She rested for a bit, that's why the line is going horizontal. And she rested for a total of a half an hour. Number 3, when was Karen riding the fastest? What was her fastest speed? If you guys want to, you can go back to the previous slide and look at the graph. From 9 o'clock to 10 o'clock, her speed was 10 km per hour. From 10 o'clock to 10:30, her speed was 15 km per hour. From 10:30 to 11 o'clock, she was resting, so that's why her speed is 0. From 11 o'clock to 12 o'clock, her speed was 12.5 km per hour. From 12 o'clock to 13 o'clock, this is military time, so technically it would be 1 o'clock in the afternoon. Her speed would be 0. From 13 o'clock to 15 o'clock, her speed was 15 km per hour. And Karen's 2 fastest riding times are from 10 o'clock to 10:30 and from 13 o'clock to 15 o'clock. And that speed was 15 km per hour. If you're unsure of how to find the speed, what you're actually doing is you're trying to find the steepness or the slope of the line. What was Karen's average speed for the whole trip? Karen's average speed was 30 plus 30 divided by 15 minus 9 equals 10 km per hour. So first you have to add together all of the speeds, which is 30 plus 30. In order to find the average, you have to divide the total sum by how many hours she was biking. So it would be 15, because that's the end of the trip, minus 9, the beginning of the trip. And you get 10 km per hour. Example 3. At the Dragon Boat Festival, Team A and Team B held a dragon boat race. The relationship between the distance, S meters, and time, T minutes, of the 2 boats is shown in the graph. What is the entire distance of this race? Which team reached the finish line first? The entire distance of the race is 1,000 meters. And here you can see that Team B reached the finish line first. Team B's reached the 1,000 meter mark at an earlier time than Team A. They reached it at 3.8 and Team A reached it at 4. Find the speed of Team B when it catches up to Team A. So Team B rode 1,000 minus 400, 600 meters after it started to accelerate. From this point here, point B started to accelerate and started catching up to Team A. And then after it accelerated, it drove at that speed for 1.6 minutes. So then you can find the speed. It's 375 meters per minute.